All right, so if you're getting started on this Hydrate Inquiry Lab, hopefully you've already made a copy of the document. Only one person in your group needs to make a copy of the document. Once you have that document, then you can share that with your group. I've zoomed in too much. You can share that with the rest of your group mates so that you can all edit that document. Once you pull that up, you'll have to share your email addresses with each other, type those in. Just make sure you have that editor there. The notification sends it to their email, then they can open it up from there. That makes it real easy. So we're going to be doing this lab on Tuesday. And the purpose of this lab is for you to get a little bit better handle on designing and implementing a procedure to answer a simple question, solve a simple problem. So you're going to be designing and implementing a method to determine the formula of a hydrate using common lab materials. If you haven't already watched and taken care of your nomenclature portion of your packet, hydrates are compounds that have water molecules incorporated into their crystal lattice. And it is generally an ionic compound. Those water molecules are not bonded with the ionic compound into a new, bigger compound. They're just attracted to the polar nature of that ionic compound, and so they squeeze themselves into any open spaces in that crystal structure, kind of like a sponge absorbing water. Unlike a sponge, though, we can't just squeeze the water out. We have to use heat to drive the water out. So I'm going to give you some sample of a crystal. It's either going to be a copper 2 sulfate or copper 2 chloride. It doesn't really matter which, and I'll tell you which one you have. And it's going to be your job to figure out what the formula of that hydrate is. You're going to be trying to find X. How many water molecules are squeezing themselves in around each of those copper sulfate or copper chloride molecules. That's always going to be a 1 to X ratio, where you have one of the ionic compound to some number of water molecules. It's always whole numbers in these ratios, just like in a balanced chemical equation. And so your goal is to design and implement a procedure to experimentally determine X. Figure out how much water is in your crystal. So in this document, you have 3 things you need to do. Write up a procedure. Find out and list out materials. I do have a link to a materials handout so that you can see kind of the general simple materials. You shouldn't need anything super fancy, not distilling anything here. Normal materials, just list them out, and then safety concerns. I have made a note about chemical safety because I just need you to be aware that both of these chemicals, whether you get copper sulfate or copper chloride, can irritate the skin, cause serious damage to your eyes, and can be harmful if swallowed. So all group members will be wearing goggles, should wash their hands and any other surfaces that come into contact with the chemicals. What I need you to focus on in your safety section is specific precautions to take with your procedure. What are you having us do, and how can you be safe while doing that? Then mention any safety equipment that needs to be used for your procedure so I can make sure to have that available for you. And you can say that either down in the safety section or up in materials or both. So you kind of have to be considering what measurements do we need to have to figure out how much water is in a hydrate. This isn't exactly an empirical formula calculation, but it's very similar to that because we need to figure out the amounts of each substance that are combined together in this hydrate. So think back on that empirical formula process, what measurements we might have needed to start with, and kind of how we would go through that process to find our given formula. So think about your measurements, think about what equipment you would need, and I need you to be as specific as possible. Don't just say, heat until water is removed. How do you know when the water is removed? What are you going to heat it to? Be as specific as possible. You will be able to alter this procedure in general when you're doing it. If you get, you want to heat it for a certain amount of time and that's not enough, you decide you need to heat it for longer or shorter time, higher, lower temperature, that kind of thing, then you can make those changes. But you need to start off as specific as possible, even if you tweak it along the way. So in class on Tuesday, I'm going to be checking in with each of the classes and approving your procedure. You've got to have some kind of step-by-step procedure, numbered list of steps before you begin the lab. I'm going to give it a quick look, make sure it has a possibility of succeeding, so you're not just like, squeeze the hydrate until the water comes out and then, measure the volume of water. That's not going to work. So you need a detailed procedure that has a possibility of working. I'll let you try it out, even if you need to tweak it along the way. And then after the lab, then you'll write it up. There's this whole second page. We're going to take data, do analysis, answer some questions. But by that point, you will have separated your documents and do that individually. So for right now, as a group, you can be talking on, editing that document together. Maybe one person's writing the procedure, the other person is making a note of materials as you need them, another person's making a comment about safety, someone else is kind of giving general feedback or helping with that procedure. So work as a group to get that procedure, materials, and safety as good as you can, as detailed as you can, so you're as ready as possible for that lab on Tuesday.